A diaphragm valve has a bell-shaped bonnet and a body that looks like two pipes that curve into the bonnet. As its name suggests, a distinguishing feature of a diaphragm valve is a flexible diaphragm that's used instead of a disc to seal against the valve seating surface. A diaphragm valve also has no packing. Packing isn't necessary because the diaphragm forms a boundary that keeps fluid from leaking along the stem. A diaphragm valve has a part called a plunger that's connected to the valve stem. A diaphragm stud connects the diaphragm to the plunger. When the hand wheel of a diaphragm valve is turned in the closed direction, the stem and plunger are lowered. The plunger forces the flexible diaphragm down against the valve seating surface, which stops flow through the valve. When the hand wheel is turned in the open direction, the diaphragm moves upward, allowing fluid to flow through the valve. The diaphragm in a diaphragm valve isn't subject to uneven wear. So a diaphragm valve can be used both for throttling and for on-off service. The diaphragm also makes a tight seal that keeps fluid from contacting the operating parts of the valve. For that reason, diaphragm valves are commonly used in applications that involve corrosive materials and abrasive slurries. In addition, some diaphragm valves have protective liners made of plastic or a similar material. The liners protect the diaphragm and the valve body from damaging fluids. In short, diaphragm valves are widely used throughout industrial facilities for a variety of applications, but they're particularly useful in systems that carry chemicals or hazardous gases. A check valve is designed to allow flow in one direction only. It prevents backflow, which is the reversal of fluid flow in the piping to which the valve is connected. As long as it's in proper working order, a check valve operates automatically in response to system conditions. The valve remains open as long as fluid flows through it in the specified direction. But if fluid flow stops or reverses, the valve closes immediately. The body of a check valve is similar to the body of a globe valve, but most check valves don't have stems, handles, or hand wheels. Most check valves do have replaceable seats, discs, and caps. The cap is the top part of the valve body, which can be removed to provide access to the disc for maintenance. It's essentially the same as the bonnet on other types of valves. Several different types of check valves are available. We will look at three of the most common. The disc in a swing check valve is hinged at the top of the valve body by means of an arm and a pivot pin. When fluid enters, the disc pivots or swings away. This opens the valve and allows fluid to flow through. The flow through the valve is fairly straight, so there's minimal pressure drop across the valve. As long as flow is constant, the disc remains raised. If the flow stops, gravity and the change in fluid pressure pull the disc onto the seat, closing the valve. If flow reverses, the backflow pushes the disc against the seat to close the valve. If flow is intermittent, the resulting turbulence can cause the disc to alternately rise and fall or slam against the seat. The disc's repeated impact against the seat is called disc slam. Disc slam can damage the disc and the seat and result in leakage around the disc. For this reason, swing check valves are generally not used in applications where intermittent flow is common. A swing check valve, like other check valves, must be installed so that the direction of flow is under the disc. This disc position is necessary to allow fluid flow to raise the disc. It's also necessary because the disc depends, in part, on the force of gravity to pull it down onto the seat. The direction of flow for a check valve is often shown with an arrow cast into the outside of the valve body. As with any type of check valve, the disc in a horizontal lift check valve is positioned so that fluid will flow under the disc. When fluid enters the valve body and system pressure is greater than the weight of the disc is lifted off the seat. Fluid flows through the valve, then on through the outlet. When system pressure is reduced or flow is reversed, the disc moves down onto the seat. Another type of lift check valve is a vertical lift check valve. Fluid flows through this check valve vertically, but the disc is still positioned so that fluid flow is under the disc, just as it is in other types of check valves. A variation of the lift type check valve is a ball check valve. As its name indicates, a ball check valve has a ball-shaped disc. Ball check valves can be designed to operate in either the vertical or the horizontal position. In this example, the valve operates horizontally. When fluid flows through the valve, the ball is pushed out of the seat by the pressure of the flow. As the ball is lifted, it also rotates in the fluid flow. Solid materials in the fluid can't easily stick to the spinning ball. So this makes ball check valves excellent for handling liquids that contain scale and sediment. Because the ball rotates freely when the valve is open, the ball tends to wear evenly. When flow through the valve stops, the ball is pulled onto the seat. A different surface area of the ball falls onto the seat each time flow stops. This produces a self-cleaning effect that also helps to ensure that the valve continues to close properly. If flow reverses, the backflow holds the ball firmly on the seat, keeping the valve closed.